Hey guys, thanks for joining. Today we're going to do sequences focusing on sigma. So let's take a look at sigma notation. This is the general form of how you will get it. But before, let's cover some theory. What does sigma mean? Sigma means the sum of. Therefore, whenever we have a sigma question, it always means we're going to use the SN formula. Okay, we can apply this sigma notation for arithmetic sequences, geometric sequences, or sum to infinity. Okay, so now there are three ways that we can get this question. We can get it here with 1, where we get the sequence. We can get it here with 2, where we just get no answer. Or we can get it here with number 3, where we get one single number. So I'm going to do an example with each of these so that you guys can understand how to work with each of them. So the first example I'm going to do is the question where we are not given anything after the equal sign. Right. So whenever we're doing a sequence or sum, we always need to find the following elements. We need to find, in this case, Sn, because we're working with sigma. We need to find n. We need to find A, and then either D or R, depending on if we're working with an arithmetic or a geometric sequence. Right. So in this case, we look at the sum, and because we are not given anything after the equal sign, we can automatically assume that we are finding Sn. That is our unknown, because no other information has been given to us. Right, our general formula for always finding n when we're using sigma is going to be the top value minus the bottom value plus 1. Now this formula you can apply in any sigma question. So in this case, it's going to be 27 minus 1 plus 1. Okay, therefore n will be 27. Now we need to work out A and then either D or R. And normally to figure out A and D and R, we need to have the sequence. And that's where this formula comes into play. What we're going to do is we're going to use this formula as our general formula in order to find the first 3 terms of our sequence. Now this number comes into play, and we're going to fill in this number into our general solution in ascending order to find T1, T2, and T3. So let's start it. Let's say T1. We're going to have 2. We're going to fill in that K, which is 1 plus 3, which would equal 5. Now, it doesn't matter what that value at the bottom is. You always start with that value. So let's say it was 2. You would fill in 2 first, right? It just depends on the general formula. Next, we want to work out T2, okay? And how we're going to figure it out is we're going to go in ascending order, and we always move up by 1 position. So now instead of filling in 1, we're going to fill in 2. We've increased the value by 2 because we're going to the next term. Plus 3 is equal to 7, and T3 is equal to 2 times 3 plus 3, which is equal to 9. Now, as you can see, we have our first 3 terms of our sequence, which would be 5, 7, and 9. From this, we can automatically see that our A value is 5. Now we need to work out if this is arithmetic or geometric. So we first do the test and we say the difference. Do we find a common difference? 7 minus 5 gives me 2. 9 minus 7 gives me 2. So we don't have to move further. We have a common difference of 2. So we can scratch out that R and put D is equal to 2. Right. Alright, so now that we have got all our elements that we need in order to solve an equation, and we know that we are working with an arithmetic sequence, we can use the arithmetic sum formula, which is Sn is equal to n over 2 2 times A plus N minus 1 times D, right? And we have all our elements, so now the easy part is we just go and fill in these elements to find to solve the equation. So N is 27 over 2 times A, so times by 5, plus N 27 minus 1, times by D, which is 2. Now, all you can do is go and fill that in your calculator, and you should get an answer of 837. Therefore, we have solved the sigma by saying 27 sigma k equals 1. 2k plus 3 is equal to 837. Sorry, there shouldn't be an equal sign over here. And that is your answer. So now you've just completed the first question where you aren't given an answer next to the equal sign. So important things to remember is our end formula, which we will use in every scenario going forward, as well as we always need to find these elements before we can do a question. And if we aren't given anything after the equal sign, we have to go and find the first 3 terms of the sequence. Okay, moving on to the next one. The next one I'm going to work with is when we have more than one number after the equal sign, or in some instances where we're only given one number and the ellipsis. Okay, the second we get more than one number after the equal sign, or get one number and the ellipsis, it is an automatic indication to us that we have been given terms of the sequence. So in this case, 5 would be term 1, 7 would be term 2, and 9 would be term 3, and the ellipsis indicates to us that the sequence continues. It is also important to notice that normally when we have a sequence, everything is divided by, not separated by a semicolon. In this case, we have pluses. Okay, why? Because we are working with sigma, and sigma means sum. So instead of getting the colon, you'll get a plus, which further indicates to us that we need to be using our SN formula. Okay, then as usual, when we're working with sequences, we need to have all our elements to solve the sum. So we need SN, we need A, we need N, and then we either need D or R. Right, so let's solve what we know already and the information we have. So A, we can automatically see it's been given to us. Our first term is 5, therefore A is 5. N, we know how to work it out. It is top minus bottom plus 1. So it would be 27 minus 1 plus 1, which gives us an N of 27. Now we've been given the first 3 terms of the sequence, so we can work out if it's arithmetic or geometric. So first we test arithmetic by doing common difference. 7 minus 5 is 2. 9 minus 7 is 2. Therefore, we can assume that it is arithmetic, and we don't have a common ratio, we have a common difference. So D equals 2. We have 3 out of the 4 elements completed, and therefore we know we're looking for Sn. So now that we have all our elements, we can go and put it into our formula, which is N over 2, 2A plus N minus 1 times by D. Right? Now we know we're working for S27 because N is 27. 27 over 2. 2 times 5 plus 27 minus 1. Times by D, which is 2. Right? Now, aim a trick, you can just go and fill this into your calculator, and you will be given S27. So the sum of the 27 numbers in the sequence gives us a total of 837. So this is how we work out when we've been given more than one number. We know that it gives us the terms of the sequence over here, and we just have to find our elements. If we were just given the 5, as I showed you here, and the ellipsis, it means that we'd be given A, and we can work out n, but you would still have to go and work out T2 and T3 in order to work out if it's a common difference or a common ratio. But then you would just do the sum like we did in the previous example. Okay. Our last example that we're going to do is when we only have one number after the equal sign. There's no plus, no minus, no ellipsis, and no other term. When we get this, we can conclude that this is actually the answer to our sequence. So the sum of our sequence is actually 837. So now we have to go and work out our elements, Sn, which would be 837 as indicated above, N, A, and then either D or R, right? And we would normally work out by saying top minus bottom plus 1. But in this equation, we can see that there's no number above the sigma sign. And therefore, we can't physically work out n. And therefore, n is our missing term and what we're solving for in this equation. So it's just another way for your teachers to ask you to solve for n by not putting any value on top of the sigma sign and giving you the answer to Sn. Right, now we have to go and work out A and then D or R. But going back to our first example, in order to work out these values, we need term 1, term 2, and term 3 of the sequence. And therefore, we're going to go back to using this general formula to find these sequences. So the exact same way we did in the first example, we're going to say term 1 is equal to TK plus 3. And we would fill in that 1. Plus 3 is equal to 5. T2, we're going to increase it by 1 because we've moved up one term. So times by 2 plus 3 is equal to 7. And T3 is equal to, plus 3 is equal to 9. We now have our first 3 terms of our sequence. Note that I'm putting an plus sign in between them because we are working with a sigma question. Right, now we can see that A is 5 because it's our first term. And now we need to work out if we're doing geometric or arithmetic. And we start by working with arithmetic. We say 7 minus 5 is 2. 9 minus 7 is 2. And therefore we have a common difference. And we can assume we're working with an arithmetic, erasing the R, giving the common difference of 2. Now that we have all our variables, okay, all our elements, we can now go and put them into the equation and solve for our missing element, which we know in this case is n. So using our formula once again, Sn equals n over 2, 2a plus n minus 1 times by d. Right? So let's go and fill in what we know. We know 837, n is missing, but 2 times a, which is 5, plus n minus 1 times by 2. Alright, so lastly we're going to solve for n, and we're just going to use some algebra techniques to put n on its own. So first thing I would do is I would times by 2 on both sides to get rid of that 2 here, so that the 2 cancels. And why we can do it is because this is a divide sign that is being times by the entire bracket. So this gives me 1674 is now equal to n. I'm going to solve inside the bracket. 2 times 5 is 10. And now I'm going to distribute that 2 into the bracket. So I get 2n minus 2, close the bracket. Right? I now get 1674 is equal to n. I'm going to solve inside the bracket. 10 minus 2 gives me 8 plus 2n. Right? My next step, I can go and distribute that n. So I get 2n squared plus 8n. Now that I've got an n, and I can see that it's a quadratic equation, the second I see it's quadratic equation, I always make it equal to 0. So 0 equals 2n squared plus 8n minus 1674. All right, and at this point, I would go and use my quadratic equation. I just find it easier, and knowing that my quadratic equation is x, or in this case it would be n, is equal to minus b plus minus square root of b squared minus 4 times a c over 2 times a. So let's quickly fill it in our calculator and then we'll get our answer. We've used our calculator, we get two answers of n equals 27 or n equals minus 31. And we know that we can't have an n with a negative. Therefore, we're going to say that this is not applicable. We can't have an n as negative because we can't have a negative number of terms. So this is how we work out the final question example. I want you to know that you can employ all of these methods using geometric sequences as well. It works the exact same way, but instead of using the arithmetic SN formula, you obviously use the geometric SN formula, and instead of finding D, you'll find R, but it works exactly the same way. An important trick with this method is a lot of people get confused at this point over here when we are timesing out that 2. I always find it easier to first times out that 2, get it to the other side, and then you're left with this, which makes it much easier to solve. Now we're going to do some tips. See, before we end off, I just want to give some tips. I want to remind you that for sigma questions, we always have that plus, right? Okay, and when we have that equal sign after the sigma, it can just be a question where it's 3 plus, and this in this case we would do an example where we have to find T2 and T3. Another thing that a lot of people often get confused of, if I go back to my sigma and I had k equals to 2 instead of 1 in this case, and we had 2k plus 3. To find term 1, we always use the first number that they give us. So it would be 2 times 2 plus 3, which would give us 7. Now when I do term 2, once again, I just move that k value up 1, and I would do 2 times 3 plus 3 is equal to 9. So an important thing to remember that this k doesn't necessarily represent the term number, but it starts from that k value and moves up 1 from that first k value. Thank you so much for watching. If you have any questions, please let me know.